Today we are going to discuss about similar triangles. This is 10th class state CBSE and ICSE. Now onwards I am going to teach all the three that means CBSE, state and ICSE together. Earlier I used to teach separately, but now it is not the case. So let us go with geometry. First chapter geometry, that is state CBSE and ICSE 10th class, and the topic is similar triangles. Similar triangles. What do you mean by similar triangles? What do you mean by similar? Can anyone tell what do you mean by similar? Similar means having the same shape but not necessarily the same size. Are you getting my point? Whereas congruent triangles means they are having same shape and same size. Let us discuss what are those about. Just I will give a brief explanation. These two diagrams, they are said to be similar because they are looking same. Now take this another example. Observe this diagram and this diagram. Now what do you observe from these two patterns? These are called congruency. Congruency means they are having same shape and same size. So both are different. That means similar and congruency are different. So congruency means if you overlap one figure or the other, they both will coincide. Whereas similar triangles, it is not the case. If you put this triangle over here, they will not coincide, but they look the same. So they are said to be similar. So let us not go deep into that. Directly we will go to theorem. Our first theorem starts is basic proportionality theorem. What does it states? BPT, basic proportionality theorem. What does it state is, take a triangle, any triangle, whether it is acute, obtuse or isosceles, draw a line parallel to one side. Draw a line parallel to one side. Then suppose this is a figure, ABC is a triangle. I am drawing one line parallel to this. So DE is parallel to some BC. What do you notice? Take different types of pictures, and when you are free at the home, take a triangle and draw parallel lines, and then observe the pattern. What you see is triangle. You will observe that AD by DB is equal to AE by EC. Are you getting my point? AD by DC, AD by DB. Take the ratio of this, measure this length and this length, measure this length and this length. They both are same. That means, what does it state is, if a line is drawn parallel to one side of a triangle, a line is drawn parallel to one side of a triangle. This is a line. I am drawing one line parallel to one side of a triangle. Then it will divide the other two sides in the same ratio. AD by DB or AE by EC, same ratio. This is the activity you need to do at home, but in examination they may ask you to prove it. State and prove basic proportionality theorem. Rather they may ask. So in order to prove this, what you need to do is, you must have knowledge about some 9th class and previous classes. You should have at least some knowledge about triangles, areas of triangles. What I am saying is, if two triangles are on the same base and between the same parallels, Listen carefully. If two triangles A, B, C, D. This is the triangle ABC and this is the triangle DBC. These two triangles, if two triangles, they are lying on the same base means BC, and between the same parallels, their areas are equal. That means area of triangle ABC is equal to area of triangle ABDC. Are you getting my point? If two triangles are lying on the same base and between the same parallels, their areas are always equal. So this one point, and another point is, you know that in an acute angle triangle, altitude always lies inside the triangle. For an obtuse angle triangle, the altitude lies outside the triangle. Okay, and that's it. If you know these two, then we can go ahead with the theorem. It's very simple. It looks to be difficult, but I will make it easy for you. I noticed that 10th class students, mainly 8th, 9th, 10th students, when they go to geometry, they feel that geometry is the toughest topic. It is not like that. Geometry is the one of the easiest topic, because you need to apply all the properties, all the basic rules which you have learned in 6th, 7th, 8th, and you should not miss a single point where you will get confused. So let us do it. Take a triangle ADE, area of triangle ADE, area of triangle ADE. So EF. What kind of triangle it is? ADE. Can anyone say? It is an obtuse, acute, or isosceles. Let us think that it is, obviously it is not an obtuse angle triangle. So it is maybe acute angle. So for acute angle, the altitude lies inside the triangle. Triangle ADE is equal to half into, what is the base? AD. What is the height? EF. Now take another triangle, this one, BDE, area of triangle BDE. What is the base here? BD, half into BD into. Now you know that clearly this triangle is obtuse angle triangle. For obtuse angle triangle, the altitude lies outside the triangle. So half into BD into EF. Half into base is BD. So the altitude lies outside. So take the ratio of these two. AD by BD is equal to, sorry, this and this will get cancelled. So area of triangle AD by BD is equal to AD by DB. Now in the same way, consider this triangle and this triangle. What I am saying is, consider triangle ADE and triangle DEC. What do you observe? Triangle, area of triangle ADE by area of triangle DEC is equal to, in the same way you can prove that one. I am not writing all those steps. You can write directly AE by EC. Right? It's clear? So simple. Just I applied area of triangle formula, that is half into base into height. That's it. And obtuse angle triangle like acute angle triangle. Now observe this carefully. These two. area of triangle BDE, area of triangle BDE and area of triangle DEC. Just now I explained before proving the theorem. If two triangles they are lying on the same base, this triangle BDE and triangle DEC, they are lying on the same base and between the same parallels their areas are equal. So from this, area of triangle BDE is equal to area of triangle DEC, right? So take it as 1, mark this as 1, mark this as 2, right? I am erasing all this. So in what you have written in this triangle AD by area is equal to, let me write once again this. I am erasing the figure now. Now it doesn't require now. Area of triangle ADE by area of triangle BDE is equal to what is the answer you got? AD by BD. Now area of triangle ADE by area of triangle BDE. What you have written here? Area of triangle BDE is nothing but area of triangle DEC. In place of BDE, replace DEC. This you write as this. But what do you see that area of triangle ADE by DEC is nothing but AE by EC. So in place of this, you write down AE by EC is equal to AD by BD. Hence proof. That's it. Very simple. So just what I did is these two areas are same. I took this one from 1. In place of area of triangle BDE, I have written DEC. The same thing I have written, but this area is nothing but you can write from 2. So that's it. So basic proportionality theorem is finished. And what is the converse of this one? Can anyone tell what is the converse of this one? What is the converse of basic proportionality theorem? So actually what the theorem states by basic proportionality theorem? If a line is drawn parallel to one side, then you will divide the other two sides in the same ratio. Next, just reverse it. If a line divides the other two sides in the same ratio, then it will be parallel to the third side. What does it mean? PQR. I am writing 2 point DE. I am joining this. Now, if PD by DQ is equal to PE by ER, then if BD by then what is it? D is parallel to QR. Just converse. Now the ratio is same, then that line is parallel to the third side. This is the converse of basic proportionality theorem. If a line divides the other two sides in the same ratio, this line is dividing the other two sides in the same ratio, then that line is parallel to the third side. That is the converse of basic proportionality theorem. Very, very important. You need to note down these two. One of the most basic important things are basic proportionality theorem and converse. Based on this, you can do many problems and some lengthy problems which are quite interesting. And you will enjoy, like how you are going to play chess, like that you will enjoy while doing these problems. So there is no need to fear. I am here to teach you and help you in a simple and easiest way. So that's it. Now let us go to one more theorem, that is vertical angle bisector theorem. What does it mean, vertical angle bisector? Vertical angle bisector theorem. So I hope you have enjoyed this class very well. In the coming class we will be doing some, because already time up, so we'll be doing some more problems, some theorems, and after that we will do word problems, numerical problems and theoretical problems. So this is my first class after a long gap, because there was some problems, that's why I could not continue with my teaching. So now onwards I will be doing continuously. Have a nice day. Thank you very much. Bye.